Looking at questions that need to be answered from this class, the number one question missed is number 18. Number 18. Okay, number 18 reads, two six-sided polygons are similar. Okay, similar means that they're proportional, their side lengths are proportional. A side of a larger polygon is 7 times as long as the corresponding side of the smaller polygon. What is the ratio of the areas of the larger polygon to the area of the smaller polygon? Well, what you could end up saying is that the one that's larger, what if the side of the smaller one had a unit of 1? Well, then the corresponding side of the other one would have a size of 7. Does that make sense? All right, so what we do is we take that ratio, and if we want to know what the ratio of the areas is, we square it, because area is squared. All right, so my answer is simply 49 to 1. That's it. So a question that 8 out of 10 people missed should go to a question that everybody in here can do, right? Right, and you would have been wrong if you'd put 1 over 49 because it wants to know the ratio of the larger on top to the smaller on the bottom, okay? So the best you could have hoped for if you'd put 1 over 49 is maybe half credit, okay? Does this answer make sense to us now? Okay, pretty easy, but easy to forget also. Let's see, next on our list is number 7. Number 7. Okay. Let's see. We got square root of 6x minus 2 minus radical 9 equals 5. Well, this one's kind of nice from a certain respect. The first thing I'm going to do is I'm going to add radical 9 to the right-hand side because I want to isolate this complex radical we have over here. So whenever I do that, I'm getting 5 plus radical 9. And what's really nice about radical 9 is what? It equals 3, so 6x minus 2, right? This should equal 8 over here, correct? All right, and if I want to get rid of the square root on the left, how can I do that? Square it. Square both sides, all right? So I got 6x minus 2 equals 64, right? Add 2, 6x equals 66. Divide by 6, x equals 11. Do we feel silly? It's exactly what you did, but oh, you know exactly what you did. I do want to check something just because in the event of of our test tomorrow, what we could have happen is it could be a similar question, but it'd be much harder. Let me see what that one looks like. Okay, so you need to be prepared on. Actually, no, it's fine. It'll be very similar to this. Basically, what I'm telling you to watch out for is it gets much more complicated if this is not a perfect square. And I'm telling you on your test tomorrow that is a perfect square. So this chain of events should be the same chain of events. Okay? All right, so that should give you at least a little bit of comfort. What did I do with that? Okay, next on our list comes between 1, 2, there's 3 questions that 6 people missed. We'll start with number 1. Number 1. The ratio of diamonds to stars is 3 to 11. So diamonds to stars is 3 to 11. Okay, we could actually take this and simplify this. That 3s is equal to 11d. Okay, and then we learned something. And 3 times the number of diamonds was 2 less than the number of stars. How many were diamonds? All right, so if 3 times the number of diamonds was 2 less than the number of stars, if I added 2 to my diamond side, it would be equal to the number of stars. Is that correct? Okay, so our question is, how many were diamonds? All right, well, what I'm going to go ahead and do is, because this bottom equation down here already solves for s, that means I can take 3 and I can substitute into this top equation. So I can write 3 times 3d plus 2 equals 11d. And what's really nice about that is that I'm going to solve for d without ever having to solve for s, because all my question asked me for was how many were diamonds. Okay? All right, so let's scroll down here a little bit. We're going to use the distributive property. We're going to get 9d plus 6 equals 11d. And I know that can be tough. Make sure that you're careful if you have to use d that it doesn't look like a 0. Okay, I'm going to subtract 9d. I'm going to get 6 equals what? 2d. All right, so d should equal what? 3. All right, does that match what you had in your answer key? Okay, good. Now, you do a little different. If you solved for s first, then all you would have to do is plug s back in and solve for d. Questions there? No? Next on the list is number 6. Number 6. 1/3 plus 4 over x plus 2 equals 5/6. All right, when we covered this, I tried to give you a little bit of a hack or cheat, which is we know 1/3 plus a fraction equals 5/6, correct? So if I treated this like 1/3 plus x equals 5/6, then what I would do is I would take 5/6 and subtract 1/3, right, to find out what x as a whole fraction equals. Right, well, that would be the same as 5/3 minus 2/6 in order to get a common denominator, right, which is going to give me 3/6, which is going to give me 1/2, right? So we know this. What does 4 over x plus 2 equal? 4 over x plus 2 equals 1/2. All right, notice that my numerator is 4. All right, what would my denominator have to be to make the fraction with a numerator of 4 equal to 1/2? 4 over what equals 1/2? 8. So I know this, and there's other, you could do this as a proportion where you're doing 4 times 2 equals x over 2, or, times 1, and you would still get 8, right? So x plus 2 equals 8, correct? All right, so what does x equal? X equals 6, because 6 plus 2 is 8. 4 over 8 is 1/2. You can go back and you can check it, which I should do if I have time. Go ahead and plug 6 in, 1/3, and check it in your calculator. 1/3 plus, okay, we know that 6 plus 2 is 8. We know that reduces to 1/2. What's 1/3 plus 1/2? Okay, well, my common denominator there is 6, and I should be able to get 5/6 back out of it, right? Okay. Any questions there? I think the book does give a more complicated way of solving it. I think this is the easiest way to do it. Okay? All right. Let's see. After 6 is 15. 15. Are we getting through some of the questions that you needed? Okay. Is this an effective way to go about doing this? Hopefully. What did I say? 15? All right, so you've got a rectangle. In it, you have a circle. All around that circle, it's shaded. Right? We've got a center to that circle. We know this side is 4. We know this side is 3 from here to there. We know this is 5. Our question is, find the area of the shaded region. Essentially, what I want you to be able to contemplate is that what we're saying is rectangle minus circle, right? That's going to be the area of my shaded region. I can find the area of my rectangle. Keep in mind, all right, that because this is tangent here, it's only just touching it. So from here to here is 5, but from there to there is 3. So the length of the rectangle is 8, right? That's not hard to get. 8 times 4. Okay, what was that, 32? 32. So we know the area of the rectangle is 32. All right. What do we know? In order for us to find the area of the circle, though, we need to know pi r squared, correct? So pi, what's my radius there? No, the whole length of this is 4, so half of it is going to be 2 pi r squared, right? So we are going to wind up with 32 minus 4 pi. And if you were trying to make it more complicated than that, that's it. I can't really simplify that any further. If you got a decimal, you need to check and see, is my decimal equivalent to 32 minus 4 pi? Because this should be in centimeters squared. This is my answer. Does this make sense? Okay. All right. Now we move on to the fives. Okay, questions 5 people missed, and I think the first one is number 2. So I apologize if you're watching the video and obviously we're not answering the questions in order, we're just answering them in order of importance. Number 2, I see people struggle with this in their homework. Jen had a total of 21 nickels and dimes. Okay, so nickels plus dimes equals what? 21. Okay, imagine you have a pile of change in front of you. We're not asking you what it's worth. We're just saying how many coins are there. Well, there's only 2 types of coins in this case. There are 21 nickels and dimes. So if I add up nickels and dimes, I get 21. Do we understand the first equation? So the first equation is always calculated on real substance. Okay, what is literally there? The next equation is always based upon value. Okay, what is a nickel worth? 5. Now, you can make it 0.05, but in order to not have to work with the decimals, I always make a cent a whole, which means all we're doing is we're moving the decimal place 2 places to the right. All right, what is a dime worth? 10, so 10D. All right, what was the value of her nickels and dimes? So in our case, 155. If you are familiar with solving by matrices, you can solve this using a matrix, right? It'd be 1, 1, 21, 5, 10, 155, and you could get your nickels and dimes that way. If we're going to solve this using just equations, what I would do is I'm going to change this first equation, and I'm going to solve it for nickels. So that means 21 minus D, or negative D minus 21. Okay, whatever. Okay, I'm going to subtract D to the other side. And what that allows me to do is now I can come into this second equation, and I can plug in 21 minus D, okay, plus 10D equals 155, and I can solve the whole equation for dimes. And once I've solved for dimes, I can go back into the original first equation and solve it for nickels. Does that make sense? All right, so first thing I do is I distribute 5 times 21, which is 105. Is that right? Okay, 105 minus 5D plus 10D equals 155. Okay, let's see, we can subtract 105, and we can combine like terms so that we have 5D equals, was that 40? No, sorry, yeah, 50, you're right, 50. All right, so D equals what, 10? 10. Now, if I've got 10 dimes and I got 21 total coins, how many nickels do I have? 11. All right, is that easier than what we were making it out to be? Okay. All right. So these questions aren't hard. It's just trying to remember what to do. Okay? Just got to remember what to do. All right. Let's see what's next. That was number 2. We need another number. We need number 10. Number 10. Okay, number 10. All right. I can see this giving us some fits. We've got cube root of x to the 6th, y cubed, and then we come outside of the radical, so we've got x to the negative 1st, y squared. Okay, and in our denominator, I'm going to do this in a different color. Okay, square root of x to the fourth, y squared. And it looks like this square root symbol carries all the way across, so all of this is under there. X, y cubed. All right, the reason I picked different colors is so that I can do all of the numerator together, and you see that. We can do all of the denominator together, and you can see that. All right, first off, I'm going to get everything out of this numerator radical by dividing my exponents by my root. Okay, so 6 divided by 3 is 2, so I get x squared. 3 divided by 3 is 1, so I get just y. I've got x to the negative 1, y squared. Because all of that's multiplication across, I can combine my bases by adding their exponents. So 2 plus negative 1 is just 1, and 1 plus 2 is 3. So I should get xy cubed in my numerator. Does that make sense? Did I make any mistakes that anybody can see? Went through that pretty quick. All right. For my denominator over here, I'm going to go ahead and multiply my exponents inside my parentheses by the exponent that's outside. So I'm getting x to the fourth, y squared, x cubed, y cubed. Now I'm going to do the same thing. I'm going to add my exponents of the same basis. So I got 4 plus 3 is 7, and 2 plus 3 is 5. All right. Now, let's see, what are they getting on this on number 10? Did I do something wrong? Oh, because we're still under a square root symbol. You're absolutely right. All of this is still under a square root. All right, thank you. I knew I was missing something. Okay, so now what we have to do is we have to pull all that underneath the square root, so we're going to divide by 2. All right, so we're getting x squared. Okay, we're getting y. We're getting x to the 3 halves, and we're getting y to the 3 halves, correct? And I've got to add those up. So I've got 2 plus 3 halves, which would be 7 halves. Is that correct? X to the 7 halves. And let's see, on our y's, we should be getting 5 halves, y to the 5 halves. Is that correct? As far as you can see? Okay. All right. Now what we need to do is we need to move these things in such a way that I still have positive exponents, but I can simplify. All right. Because 7 halves is bigger than 1, I don't want to bring my x up. In fact, I want to bring my x down. So we're going to bring this x down. So we want to take 7 halves minus 1. And because 5 halves is smaller than 3, we're going to move our y up and take 3 minus 5 halves. Okay, so my final answer should be 3 minus basically what? 5 halves is 1.5. Is that right? 3 halves is 1.5. So you're subtracting 2.5, so you're left with 1/2, is what you're saying. You're just kind of skipping there. Okay. All right. And then we take 7 halves minus basically 2 halves. So you would be winding up with 5 halves, right? All right. So this should be my answer. And I know I said a lot without writing a lot. Did we follow that? It can get complicated with these fractions. Hopefully you guys were able to follow that. If you didn't follow it, maybe don't do this question tomorrow. Not going to. Okay. All right. Let's see. What was after number 10? This may be the last question I have time for. It looks like number 14. What's that? This is the one you need? Okay. All right. I'm going to do my best here to get this done. Something to this effect. All right. Let's see. 8. Are you guys taking off on me? D. 6. We also know that this is 8. Our question is, what is AC? All right. That is a line that goes from this back corner down to this front bottom corner. Okay. In order to find that, we're going to have to do some mathematical gymnastics. First thing that we're going to do is we're going to solve this right triangle that's on the ground, okay? Because what we're end up forming here is a right triangle that divides. So in order to find this length right here, we're going to do 6 squared plus d squared, okay? So that's 36 plus d squared, okay? That, let's see, equals my c squared. So that's 36 plus d squared. Let's see if I've got that. And that's AB is the square root of 36 plus d squared. Okay, so that's that line right there. And if you'll notice, this is my 8 is my other length. So 8 squared plus the square root of 36 plus d squared squared equals AC squared. Okay, well this is 64. If I square that, I get 36 plus d squared equals AC squared. Okay, 36 and 64 is 100. So 100 plus d squared equals AC squared, but if I want just AC, I have to square root that equals AC. If you wrote 10 plus d, you're wrong. It is the square root of 100 plus d squared. That is it. Okay, that's my answer. And I guarantee you'll solve this exactly the same way, but with some different numbers and a different variable tomorrow. Okay? All right. Did I answer the questions that you needed to be successful tomorrow, or are there still questions that you need? If so, I will try to make a second video without you. What questions do you feel like you still need? Number 3 is a question that's still needed. What else? Is there anything else? What? Okay. What do you? 3 gets it for you too? Gets it for you? Okay. Michael, David, any? 14? We did that one, didn't we? I did that one. I just did that. Okay. Anything besides 3? No, you're all good. If I just did 3, you'd be fine? Number 20? Okay. 3 and 20. All right, I'm going to try to do these as you guys leave, so it's all part of one video. Yep. Okay. 3. Find 3 consecutive even integers such that twice the sum of the first and the second is 8 more than 3 times the third. So 3 consecutive. So if we said this is just going to be 3. A plus B, or sorry, A, B, and C. Okay, 3 consecutive. Let's see, if we say that we have A, then B is just A plus 2. Okay, for instance, if A is 2, then B is 4. Okay, consecutive evens, which means C is just A plus 4 because we're going up consecutively. Okay, find 3 consecutive even integers such that twice the sum of the first and the second. So 2 times the sum of the first and second. Well, that would be A plus 2. Okay. Let's see. Sum of the first and the second is 8 more than, so we need to subtract 8 because we're too big. Then 3 times the third equals 3 times A plus 4. So if we can solve for A, we can get the rest of them. All right. So let's simplify here. We got 2 times 2A plus 2 minus 8 equals 3A plus 12. 4A plus 4 minus 8 equals 3A plus 12. 4a minus 4 equals 3a plus 12. Add 4, subtract 3a. So a equals 16. And if a equals 16, then b has to equal 18, then c has to equal 20. And that's how we do that. All right, number 20, and then we're all done. Number 20, find the surface area of a right circular cone whose slant height is 9 inches, whose base has a radius. All right, so we got this right circular cone. Okay, slant height is 9 inches, radius of 3 inches, and we want the surface area. All right, well, the surface area of a cone is pi r squared plus pi r l. Okay, so pi 3 squared plus pi times 3 times 9 should give me 9 pi plus 27 pi, which is 36 pi inches squared. And that's it. All right, I think we're done.